All right, folks, it's back in action here. In this video, we are going to actually apply the sum and difference formulas that were developed in the previous two videos. The first skill that we want to get comfortable with, or really first two skills, is recognizing when we need to use the sum and difference formulas and recognize when the sum and difference formula has already been applied for us, okay? These are going to be two separate skills that we need to be able to get comfortable with because, of course, all the questions are going to get mixed up. Now, on this first example that we want to look at, we want to automatically remember that the tangent of pi over 3 plus pi over 4 is not equal to the tangent of pi over 3 plus the tangent of pi over 4. You do not just take the individual tangent values. Instead, we are going to apply the formula that we developed. Okay, so instead we're going to apply that, and that's going to look like the sum of the tangent values in the numerator, so the tangent of pi over 3 plus the tangent of pi over 4. And remember, we know this is going to be a plus because the sign matches in the numerator. Then in the denominator, we're going to do 1 minus the product of those two tangent values, tangent of pi over 3 and the tangent of pi over 4. Now we can start to just substitute in. We know from our unit circle that the tangent of pi over 3 is a radical 3. We know that the tangent of pi over 4 is just 1, so we're going to say plus 1. In the denominator, then we can say 1 minus, and since we already have those values, we could fill those in. Now, you might not need to actually rewrite them, but I'm rewriting them for us right now just so that we can remember. So this is really just going to be radical 3 right here. Now, what we want to do is we want to actually start rationalizing this. So if you think back to some of our past tests that we've done, I didn't have you rationalize this before, but now we're going to. So we're going to look at this denominator, and we're going to multiply this by its conjugate. So we're going to multiply this by 1 plus radical 3 and 1 plus radical 3. I've found that for many students, it's really helpful to put parentheses around all of that. Helps you keep track a little bit better as you're foiling things out. So then, as we foil this out, as we just start foiling, we're going to end up with our square root of 3, and then plus our plus a 3, plus a 1, plus another radical 3. Should have used an arrow there. And then in the denominator, we're going to have a 1 minus a 3. Although we didn't probably need to write them all individually here, I'm going to just caution you, it is much more helpful for you if you write them individually because they are going to get a little crazy here in a while. So when we collect all of our like terms, we're going to have 4 plus 2 radical 3. That's all going to be over a negative 2. So then we could reduce that. Everything's going to reduce down, and we're going to have a 2 plus a radical 3 over a negative 1. And we don't want to leave a negative in the denominator like that. So we're going to move it to the top and distribute, and we'll have a negative 2 minus a radical 3 as our final answer. Okay, that's our first sum and difference example. Tangent is probably the most complicated. Now the next one is going to be 15. Now we don't know how to do 15 because 15 is certainly not an angle from our unit circle. So what we need to do is we need to think of what two numbers could we add or subtract together to get 15. And this one's a pretty easy one. We could rewrite this one as the sine of 45 minus 30. And what we want to remember is that's not equal to the sine of 45 minus the sine of 30. We need to expand it using that sum and difference formula. And remember, our pattern is sine, cosine, cosine, sine, and on sine, the sign stays the same. So that's a minus, so this is a minus. Then we can go in and we just fill in our angles, 45, 30, 45, 30. Now we just have to evaluate. The sine of 45 is a radical 2 over 2. The cosine of 30 is a radical 3 over 2. Minus, Now the cosine of 45 is radical 2 over 2, but the sine of 30 is 1/2. Since all these denominators are going to be the same, we can automatically jump straight to the first term becomes a square root of 6. The second term is a square root of 2, and it's all over 4. If that denominator was negative, we would need to move it to the top, but it's not, so we don't, and we're done. Now, the next problem that we're going to look at is when we look at this and we scan through this, we think, oh, well, I don't know how to do 25 degrees or 65 degrees or this 5 pi over 8 or this 7 pi over 24. I don't know those values. But what I do recognize is that the pattern that I have here is a pattern for one of my sum and difference formulas. I have sine, cosine, cosine, sine. That is the sine sum formula. So this can be written as sine 25, 65, and since that's a plus, this is a plus. Well, 25 plus 65 is 90, so this just becomes sine of 90, which of course I know is 1. So I don't actually even need to use and go through the whole formula. I just needed to recognize that it had been used. A similar thing is going to happen on this next one. What I'm going to notice is that I have cosine, cosine, sine, sine. So I'm going to pull this together and say, hey, that's a cosine formula. Erase that. I'm going to say that's a cosine formula. And that's going to be 5 pi over 8 and 7 pi over 24. And then since this is a plus, remember the cosine formula is opposite, so I'm going to fill this in as a minus. Now I just need to get common denominators. So this is going to get multiplied top and bottom by 3. So this becomes cosine of 15 plus my 7, or sorry, I meant to say 15 minus my 7, is going to become 8 pi over 24, which means I have cosine of pi over 3. And of course, cosine of pi over 3 is just 1/2. And then I'm all done. Okay, so that takes care of that one. Now, the last one that we're going to do today, and then we have another one that we'll do in class, but the last one that we're going to do is interpreting these pictures right here. So what we're going to notice is that they gave us some equations for some circles. On the first one, we're going to recognize that this radius here is 4, or the radius here is 2. I meant to say the equation equals 4, so our radius is actually only a 2. And they've given us a y-coordinate of a 1, which means we could do a little Pythagorean theorem here, or if you're recognizing that this is from our unit circle, we're going to end up getting a square root of 3 there. On the next one, this one's going to look a little bit more complicated for us. We'll notice that the radius of our circle is going to be 1, and they gave us this x-coordinate of 1/3. Now, most people don't actually want to have to work with those fractions there, so what we can do is we can rewrite this problem by getting rid of this fraction. So we're going to multiply both of these values by 3. So this is going to turn into a 1, and the radius is going to turn into a 3. Now I can do a quick mental Pythagorean theorem, and I'll have 9 minus 1 is 8. So that's going to give me a negative square root of 8, which is a negative 2 radical 2. And now I can use those values for my problem. So this first picture over here is going to represent angle A. The second picture is angle B. I wrote over the A and the B on that problem when I was doing that. So you might have already noticed it before I wrote over it. Now, the problem wants us to do tangent, and it wants to do the difference of these two angles. So we're going to write our formula first. We're going to say tangent A, but the numerator is going to, in this case, be the difference of the two tangent values. The denominator is going to be 1 plus, because the sign has to be opposite, the product of those tangent values. Now what we're going to do is we're going to read from our picture. So tangent of A, we're going to come over here to our triangle and we're going to read from our triangle. So our opposite over our adjacent. Now, most people are going to want to rationalize this, but as you get some experience, you're going to find that sometimes it's a little better to actually not rationalize, and this is one of those cases. So I'm going to say 1 over a radical 3, and then I'm going to subtract the tangent of the second triangle. So again, stand here, opposite over adjacent. That's going to be a negative 2 radical 2. Put that in parentheses so I don't lose track. Those of you who are tiny writers, I want you guys to give yourself some space on this. Do not try to make this too scrunchy. That's going to be all over 1 plus, now I'm going to have their product, 1 over radical 3 and 2 radical 2. Almost lost my own negative there. I'm going to make it even a little darker, over 1. Now, we've talked about this before, we want to make the denominator in the numerator the same as the denominator in the denominator. And I know that always sounds confusing, but that means that on this one, I'm going to multiply top and bottom by a radical 3. And in the denominator, I'm going to have a radical 3 over a radical 3. So now I have this whole denominator is radical 3. This is all radical 3. So I can clean this up very quickly and it'll become 1. Watch your signs carefully here. This is going to be minus, so I'm subtracting a negative. So it's going to become 1 plus 2 radical 6. Got to be careful with those radicals. And in the denominator, I'm going to have a radical 3. Don't lose this negative. That's why I made mine darker, because I almost lost it. Minus 2 radical 2. Okay. Oops, I meant to say radical 3 there. Now, oh, that still looks really kind of messy. Let me clean that up for you guys. Don't want anybody to get confused. Sorry about that. The iPad was slowing down on me there. Okay, now we are going to rationalize this. So top and bottom is going to get multiplied by radical 3 plus 2 radical 2. Radical 3 plus 2 radical 2. Parentheses, 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 parentheses. It's going to really make a difference for you. I know this one is long. Now, this is where I was saying writing everything out is going to be helpful. This is going to give me a radical 3. This is going to give me a 2 radical 2. Then I'm going to have a 2 radical 18 and a 4 radical 12. Do not try to do this stuff in your head. You will end up getting yourself confused. In the denominator, I only need to worry about these two terms. So I'm going to have a 3 minus 8. Now I can start cleaning things up. 2 square root of 18 is going to simplify to a 6 square root of 2. And 4 square root of 12 is going to simplify to an 8 square root of 3. The denominator is going to simplify to a minus 5. Now I can collect all the like terms. So in the numerator, I've got this and I've got this. So I've got an 8 radical 2. Then I have a radical 3 and an 8 radical 3. So now I'm going to have plus a 9 radical 3. It's all over a negative 5. And I mentioned this earlier, we do not want to leave that negative in the denominator. So we're going to take the negative from here, we're going to move it to the top, and we're going to distribute. So our final answer is going to be a negative 8 radical 2 minus 9 radical 3 all over that positive 5. It's going to clean that all up and give us some consistency on our answers.